Hello?
I think there is I think I didn't turn on the audio. Can you hear me, Shana? Hello. Good evening.
Yeah, I can hear you now.
Hi there.
Hi.
Did you finish the homework?
So I tried the homework problems on the website and
Okay.
they were too hard for me.
Okay.
And so I was thinking like it's not where I want to like focus on right now because
Okay.
I have to prepare for these two contests that are coming
Okay.
soon. And
Okay.
I don't have like the time right now to like watch videos and practice the
Sure, sure.
trigonometry.
Okay. Okay, no
So we
problem.
can do it later on, like in the summer when I'm ready.
Sure, sure. No problem. So which chapter you want me to prepare today?
I think I sent you the Cayley contest that we can discuss today.
1 minute. I didn't check the mail. I'm sorry. I'll just see. Okay. Shana, could you please also ping me on the WhatsApp hereafter if you send any mail?
Okay.
Oh yeah, I just saw the Cayley contest. The question 9, 17, 23, 25 wrong. I attached paper and solutions. Okay.
But I don't think we need to discuss question 9. That was easy one. So
Okay.
that was
You need to discuss from question 17.
yeah.
Okay.
Okay. I can send you the contest paper and the solutions in the chat.
Yeah, I just saw the mail. I saw. You sent me yesterday, right?
Yeah.
Yeah. 1 minute. I'm just opening the Gmail. Yes.
So I sent the link of the website with all the past contests in the chat. That's the one. That's where I have the Cayley contest and the
Okay. So when are you appearing for this contest?
the Cayley contest is in February and the Galois is in April, I think.
All
One
right.
of them is like multiple choice, like you
Okay.
choose the answers, and
Okay.
then the second one is um open response.
Okay. You said question number 17, right?
Yeah.
Okay. I hope you're able to see my screen.
Yeah, I can.
This is the question, right? Is the question is correct? The 17 one?
Yeah.
Okay. So Carly made treat bags. Each bag contained exactly one chocolate, one mint, and one caramel. The chocolates came in boxes of 50. The mint came in boxes of 40. The caramels came in boxes of 25. Okay. So Carly made no complete treat bags and there were no unused chocolates, mints, or caramels. What is the minimum total number of boxes that Carly could have bought? Okay. So Carly made no incomplete treat bags means all of them were complete, isn't it?
Yeah.
Okay. Okay, I'll just see the solution once. Okay, so in the question, they already said it's just one, exactly one chocolate, one mint, and one caramel. So you can assign some variable to this treat bags. I mean, for chocolate, you can assign X. For mint, you can assign Y. For caramel, you can assign Z. So They have just assigned these alphabets for them. So they said, the chocolates came in boxes of 50. So it is 50 times X,
Yeah.
right? So which is why we do have, Carly will then have 50 chocolates. Similarly, and they also said the mints came in the boxes of 40. So the mint is Y, so it's going to be 40Y. The caramel came in boxes of 25, so it is going to be 25Z.
Yeah.
Yes, so 50X for 50 chocolates, 40Y for 40 mints, 25Z for 25 caramels. All right.
Mhm.
Okay, till here we are clear. Okay, so in the question, what they have mentioned, since the contents of each bag was the same, Carly made no incomplete treat bags and there were no leftover candies. Then it must be the case 50x is equals to 40y is equals to 20z. Do you understand this?
Yeah.
Okay. So in our question, they're asking us to find the minimum total number of boxes. So you know total means you will go for addition, right? They're
Yeah.
saying minimum. Minimum means you will add the least value. So the least value could be one chocolate, one mint, and one caramel, isn't it?
Yeah.
So it's simply x, y, and z. So when you add them, you will have x plus y plus z, right? So x plus y plus z is going to be the minimum possible positive value of this condition. Is it clear?
Yeah.
All right. So they're asking, so you should not leave any candies. You have to include all of them. You have to include chocolate, you have to include mints, you have to include caramel,
Yeah.
which means you should find the common factor or all the three, isn't it?
Mm-hmm.
Because you are going to include everything. There is no leftover candies, isn't it? So you have no leftover candies means you are including all the three types inside the box, right? So you will go for common factor. So what they're doing, they're finding the common factor of this. What could be the HCF of this? What is the HCF of 50, 40, and 25? I mean, sorry, common factor of this?
5.
5, simply 5. Because the question is about the minimum possible positive value. So we are going to divide everything by 5. So it becomes 50x by 5 equal to 40y by 5 equal to 25z by 5. So 50x by 5 becomes 10x, 40y by 5 becomes 8y, 25z by 5 becomes 5z. Can you follow
Yeah.
this?
Yeah, because you're dividing everything by 5.
Yeah. All right. So they have asked for the minimum possible positive value. So we need to look for the smallest multiple of 10, which is also multiple of 8. First, they are taking these two. They are taking 10x and 8y. They say they are equal. 10x is equal to 8y. Since
Mm-hmm.
10x is a multiple of 10, 10x is a multiple of 10 and 8y is a multiple of 8, we can say 10x is equal to 8y.
Yeah.
So when you write multiples, 1 10 is 10, 2 10 will give you 20, 3 10 will give you 30. It goes on like that, right?
Mm-hmm.
We have to also see about the 8. 1 8 is 8, 2 8s are 16, 3 8s are 24, 4 8s are 32. It goes on like that. So
Yeah.
if you check their multiples, multiples of 10 and multiples of 8, since 10 20, 30 are not the multiples of 8, right? Multiples
Yeah.
of 8 is 8, 16, 24, 32. They are different. They are not common. They are not
Yeah.
common, right? They are not common. So 5 eighths are 40, we know that. 4 times of 10 will give you 40. So here you
Yeah.
can see the common multiple, right? So 40 is a multiple of 8. So then that must be the smallest possible value of 10x. Can you
Mm-hmm.
follow this?
Yeah.
So from this we can say 10x could be equal to 40,
Yeah.
right? So from this you can find the value of x. Basic simplification. So you'll be able to find the value of x, right? And you know how to find the value of y. And how will you find the value of y? 40 is equal to 8y, right?
Yeah.
So 40 upon 8 will give you
Why?
5. So y is 5. And 5z is also equal to 40. So z is equal to 40 upon 5. So this also will give you 5 eighths are 40. So z is 8. So you're just equating all these three things to 40 for finding the values of x, y, and z. So in our question, we need to find the minimum possible positive value of x plus y plus z. That is our aim, right? So you just have
Yeah.
to substitute these three values over there. So which gives you 4 plus 5 plus 8. The answer is 17. Can you follow this?
Mm-hmm.
So you just keep this thing in your mind. They gave you varieties of like you do have several choices. They're asking us to do some packages. You're going to mix them. Okay. They're asking you to find the minimum possible positive value out of it. So for that case, you just have to go for the common factors and multiples concept. Always you just keep this thing in your mind, like LCM and HCF. It's not a big deal. Very basic concept. So here, the very important thing is we are dividing this by common factor of 5. That is an important point. And also, we found the value of 10x as 40. This is also
Yeah.
very important. And we found the multiples. Okay, this is just a basic algebraic question. We'll move to the next question. You said you have to discuss 23, right?
Yeah.
Question number 23. Okay. What is it about? Okay, I need to read the question. Ricardo wants to arrange three ones, three twos, two threes, one four. Three ones, three ones, three ones, three twos, two threes, and one four. Okay, to form nine digit positive integer with the properties. Okay. So you're going to create a 9 digit. Let's check whether we do have 9 digits or not. 3, 3,
Yeah.
and 3. Okay, you do have 9. So you're going to create a 9 digit number from these. The condition is when reading from left to right, there is at least one before the first two, at least one two before the first three, at least one three before the four. Oh my god. When reading from left to right means you will go like this, right? Okay, we'll just try to arrange it. At least one before the first two. At least
So
one. Okay.
so we know that for sure the first number has to be one.
Yeah.
because
No,
it
no, no,
has
no,
to.
no, no, no. The the first number no need to be one. They're saying one before the first two.
Yeah.
You do have three twos here. This is first two. This is second two. This is third two. Okay. They're saying there should be at least one before the first two. Can you follow?
Yeah, but if you put like 4 first, then you can't put 2, 3, 1. You have the 3 has to be before the 4, at least one of them. And you can't put 3 first because you need a 2 before the first 3. And you
Oh,
can't put 2 first because you need the 1 before the first 1.
oh, okay, okay, okay. Yeah. Yeah, then one must be the initial one. Yes.
Yeah.
Okay. So at least one, two before the first three. Okay, this could be. You can put three over here as well. At least one, three before the first four. You can start like this also, right? One, two, three, four. No digit two can be next to another two. Okay. So I have used these four numbers. I have used 1, 2, 3, and 4. I'm not supposed to put two consecutive twos, right?
Yeah.
So I do have um, remaining two twos, two ones, two twos, one three. So I can put it in this way also, right? Can I
Hmm.
do this?
Yeah.
Actually, we'll have so many possibilities. Okay, that is the question. So in the question, they're asking, for example, integer 1, 2, 1, 3, 2, 1, 2, 3, 4 satisfies these properties. In total, how many such 9-digit positive integers can Ricardo can make?
Yeah.
Wow. Brainstorming question. Let's see the solution. I think this we can solve this using the NCR and NPR. We have discussed this, remember?
Yeah.
In the
I think.
probability, we have learned that. We'll see. I'm not sure whether they have used the same concept or not. Oh, they have divided into several cases. Okay, we'll discuss this. Okay. Okay. So, oh, 1 minute. I'll just see whether I would be able to copy this question
Okay.
in the same page. I'm not able to copy it. 1 minute. Oh, it will come like this only. I'll try to use it from Zoom. Okay, this should be fine. Suppose that n is an integer that satisfies the given properties. The first digit of n must be 1. Since there must be at least 1 before the first two, at least 2 1 before the first three, at least 3 1 before the first four. I mean, before the 4. Okay, this one you already got it, right? You told me that the first digit is going to be 1. This you can follow, right? This point you can follow this, right? Are you able to understand this point?
Oh yes, sorry, my mic was off.
Okay, you are able to understand this first point, right?
Mm-hmm.
Yeah. So since there are 3 ones in n, yes, you do have, I'll write down this as well. 3 ones, 3 twos, 2 threes, and 1 4. Okay. Since there are 3 ones in n, then n can be, the n can begin with 1, double 1, or triple 1. The first digit of n that is not a 1 must be a 2. Thus, n begins with 1 2 1 1 2 1 1 1 2. You are just following this condition now. So in this condition, they already said before the first 2, you should use 1. They said at least 1. What do you mean by at least 1? It can be 1 or more than 1 once. Do you understand? At least 1 means from this word itself, you can get the solution. At least 1 means 1 1 or more than 1 once. Can you follow?
Yeah.
Yes.
Yeah.
So I can use 1 2 1 1 2, or I can use triple 1 2.
Yeah.
All right. All right. So this is clear. Now we'll go to the case. So now you are going to take, now you are going to assume your 9-digit number. Okay, you are going to assume the 9-digit number is capital N. Okay, so that
Yeah.
capital N is going to begin with 1 2. So in the first case, since no two twos can be next to each other, this is given in the second point, right? They told us you can't use two consecutive two twos. I mean, you can't use two consecutive twos. Okay. So we next place the remaining two twos. So reading from the left, these twos can go in position. Okay, let's put the positions. Okay. I'll just draw a box. For, okay, maybe I can put a big one also. 1 2 3 4 5 6 7 8 and 9. Okay, I'll also write their position. 3 2 5 6 7 8 9. Okay, this is just to fill their positions. Okay,
Okay.
so reading from the left, so we are assuming that it is going to start from 1 2. Okay, we have filled the first 2 boxes. So
Yeah.
twos can go in positions 4 and 6, 4 and 7, 4 and 8, 4 and 9, 5 and 7, 5 and 8, 5 and 9, 6 and 8, 6 and 9, 7 and 9. So I'll show you how. Why not 3? Can you tell me why you are not, you shouldn't put 3 over here?
Because we can't have two consecutive twos.
2 consecutive, yes. So to avoid that, you are completely ignoring the 3, right?
Yes.
So you can only think about from the 4th position. Okay. So in case you are filling 2 over here, you're not allowed to fill at the 5. So you will fill it here. And also you will fill here, right? So it would be 4 6 or 4 8, right?
Yeah.
Or else you will start, if you are starting with 5th position, if you are starting with 5th position, you should not include it in the 6th position. You will include it in the 7th position, and you can also include it in the 9th position. So you will
Yeah.
also have 5 and 7, 5 and 9. Okay, what if I ignore this 2? I have included, I'm starting with okay, I have included the 2 in the 5th position. I can ignore this and I can also ignore this. I can put 2 over here. This is also allowed. So 5
Yeah.
and 8 can also be the option, right? And I can also ignore this. I can leave 3 empty spaces also. That is not going to create any problem, right? I can also put 2 over here. So it can
Yeah.
be 5, 7, 5, 8, 5, and 9. Can you follow?
Yeah.
All right. I hope you are able to understand this condition. So similarly, you're going to start with 6. So if you're starting with 6, definitely you will ignore the 7. You can't put next to it. So it will be 6 and 8. You can also put 6 and 9. Okay. If you're starting with 7, it can be 7 and 9. Yes.
Yeah.
All right. Okay. I hope this thing is clear. We'll move to the next point. In other words, there are 10 possible pairs of position in which twos can be placed. They are just counting it, okay? So there is no other go. You have to count it. Of course, it will take time, but you need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right?
Yeah.
Just give me a second, please. Okay. So the next point is, once the twos are placed, there are 5 positions left open. What does it
Yeah.
mean? So you have already filled 1 and 2. You are learning about filling the twos, right? So you do have
Yeah.
2 more twos, right? So 1, 2, 3, and 4, right? So
Yeah.
you have already filled 4 digits out of 9 digits, right? So 9
Yeah.
minus 4 will give you 5 digits. So we still have 5 positions left open. 5 positions left open. Can you follow this?
Yeah.
Uh, all right. So next we place the remaining ones, okay, because you have only filled 1 ones and 3 twos. Still you do have 2 ones, 2 threes, and 1 4. All right. So now we are considering the remaining 2 ones, okay. So
Yeah.
now we do have only 5 positions. Okay, we do have only 5 positions. So I'm going to draw a box for these 5 positions again. So it's going to be 1, 2, 3, 4, and 5. So they are calling these positions as A, B, C, D, and E. Okay. All right. We see that there are 10 pairs of positions in which ones can be placed. Okay, let's see that. So you can place the remaining 2 ones over these 2 places. You have A and B, and you can also place, because We don't have any conditions about ones. You can also place them consecutively, right? So A and B is possible. A and C is possible. A and D is also possible. A and E is also possible. Okay. So we are done with A. We are done with A. Let's start with B. Let's start with B. So what happens when you start with B? You can fill B and C. You have two ones, right? So B and C. And you can also fill B, D. You can also fill D and E, right? So we are done with D. Now let's move on to C.
Yeah.
Let's move on to C. If you put C over here, you can also put CD. You can also put CE. Only you have two options. And also, we are done with C now. Let's start with D. So if you're starting with D, you can put D and E, right?
Yeah.
You can follow this, right, Shana?
Yeah.
All right. So if you count them, AB, AC, AD, AE, BC, BD, BE, CND, CNE, D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You do have 10 pairs of positions. Is it clear?
Yeah.
All right. So 10 pairs of positions. So we are done with these two ones also.
And then there's just the 3s and the 4s.
Yes, yes. Only 2 3s and 1 4, right? So you just have to fill the remaining 3 positions in the 9 digits. Okay. So only 2 3s and 4 must be placed. All right. So still we are doing only from reading. I mean, we are doing from left to right. Okay, remember that. Okay. So reading from the left, 3 must be placed in the first empty position. Since there must be a 3 before the 4. This leaves 2 positions in which remaining digits 3 and 4 can be placed in any order. You can place them like 3 4 or 4 3. This is also possible.
Yeah.
So, like how we solved the two ones for A, B, C, D, E. You had 10 options, right? Similarly,
Yeah.
you're going to have 10 choices for 3 and 4. Okay. You want to have another 10 choices for 4 and 3. Okay. And two more.
Actually,
Yeah.
wait. You have the 10 choices for one, like in the beginning, the ones and the 2s, and then you have for the the rest of the 2s, and then you have for the 3 and 4, you have 2 possible.
Oh, yeah. Okay. Actually, from 3 and 4, you do have only 2 possibilities, right?
Yeah.
Okay.
And then like this part, there's
This
also
10 and this 10 is from here and here, isn't it?
yeah.
All right. So you're just multiplying, you're just multiplying all of them for finding their possible value. So it's 10 into 10 into 2, which will give you 100 times 2 will give you 200. So
Yeah.
we'll be having 200 possible integers for these 9 digits. So again, you're going to follow the same strategy, but now it's going to be 1 1 2. So we discussed the case which begins with 1 2. So now we are going to discuss the case which begins with 1 1 2.
Okay.
Okay. This is also quite similar. Can you explain this? You just give a try. You give a try.
Okay.
Try to explain it in the screen. I will also help you out.
So since no two twos. So we first start with 1, 1, and then 2. So since no two twos can be next to each other, we have to place we have to place 2 more twos. And you can't put wait, let me make the chart again, the box. Okay.
Can you make it in the screen? Actually, I have allowed you to share the screen. Now you tell me if you want me to do it, I'll do it.
Okay, yeah, I can do it.
Okay.
Okay, so okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Okay, so now we have 9 numbers. And so the first one we have 1, 1, and then 2. So we still have to place 2 more 2s. But we can't put a 2 there. So we have to put, we can put it here and here, here and here. Then we can put 2 here and here. Or we can start in this square and we can go here and here, here, and the last square. Or we can start in this box too. Then we have to start there and there. And we can't put in this box because if we put it in there, then we have to put the last 2 in here. But you can't have 2 2s beside each other. So we have 1, 2, 3, 4, 5. I mean 1, 2, 3, 4, 5, 6 possible ways to put the 2s. Okay. So now we know that there's 6 possible pairs for the 2s, and now we have to put all the 1s. So we already put 2 1s over here, so we have to put 1 more. So we can put it in, since we already placed the 2 2s and we placed 2 1s, that means we placed 5 numbers already. So that means we only need to put 4 more digits. So there's 4 spots for the 1s to go. So that's just 4 possibilities left. So there's 6 possibilities to place the 2s and 4 possibilities to place the 1s. So now we have to place the 3 and the 4. So far we placed 6 digits, so we just have to place 3 more. So same thing like the last one, we have to place the 3 first, and then we have to place the 4 and 3, or we can do 3, 3, 4. So that's 2 possibilities. So then we just have to multiply them and we get the total, which is 48.
Yes. Yes. Can you also try the third one?
Okay.